I've got a project for you to work on. I call it the Reconfigurable Adult Fidget Spinner project. It kind of goes like this. You've got an area. Ignore this little bar here. There's an area, and what I want you to do is make something where you can reconfigure that area. Now my area that I've cut out here on the laser cutter can't be reconfigured. It's just a cross section from an I-beam. But what I'm trying to do with this project is have you make something where you can get a feel for the second moment of area. Now really we're dealing with a moment of inertia. Really it's how the mass is distributed about this axis that makes it difficult to spin, you see. Of course the farther away the area is, the harder it'll be. But if we spin this fast enough, then the air drag out here will be greater than here. And if we have more area here, we should be able to feel that. Now what I want you to do is be able to hold the area constant with your fidget spinner, but be able to move it around, be able to move the area away from the centroid, perhaps be able to move it out parallel to the axis. And the idea then is that you'll include the ability to spin the area and be able to feel the difference as you reconfigure the area. It doesn't mean that you need, an infinite number of positions to reconfigure this thing. You could have just say 2 configurations of it if you want, but you need more than one configuration. I've only got one here. But the question is, can we make something where you can experience the second moment of area? And of course the idea here is, even though the area out here, yes, air would push harder on it, that's still the first moment. So why is it the second moment? Well, it turns out that if we could reach a high enough velocity, then the force would be proportional essentially to the square of that velocity because of drag. And so that's the basic idea. Now one thing that's really important, you have to know what axis you're talking about. You see, the amount of resistance I will experience spinning the axis this way, which with the second moment of area I'd be, the centroid's here, and I'd be taking the square of the distance to each individual differential area and adding them up. That's what integration does, right? So I'd be interested in how the area is distributed, away from the axis, not along the direction of the axis. That's a totally different thing than this, where I change the axis, and now I'm considering, hope my tape holds. Let's see, I've got another piece here. There we go. And now I'm considering how the area is distributed about this axis, you see. That's a totally different thing, right? The area is not as far away. There's still as much of it, but it's not as far away from the axis. And so make sure that you're spinning your area correctly. Some students make the mistake of thinking that I'm asking them to make something very much like a fidget spinner where there's an axis going straight through the area and you're just looking at it spin this way. That doesn't make any sense because the area we'd be looking at is just this little bitty edge area. Okay, we don't want to do that. We want to look at the bulk area. So a key here is that the axis has to lie in the plane of the area. So there's one valid orientation. Here's another valid orientation of the area relative to the spinning axis. So that's what you're supposed to do. You're supposed to make some type of reconfigurable adult fidget spinner.